So let's take a look at something that looks rather intimidating on the surface. It's called fractional exponents. Two things that most students don't really love too much. Now we know what a fraction is. We know what an exponent is. We're going to combine them. For example, let's take it this one. How about 8 to the 2/3? We have the fraction, we have an exponent, all in one. We're going to work through this and try to put this into a little simpler terms to understand what it is. So I'm going to start with an example over here. The number 9, how about 9 to the power of 1? 9 to the power of 1 is just 9. Because anything to the power of 1 is just that number. Another thing I do know is that I can add, the exponents add when you multiply them. So 9 to the 1/2 times 9 to the 1/2 is 9 to the 1. Okay, pretty good, pretty good. And what else are we looking at here? Here we have a number times itself to give me the number 9. What number times itself gives me the number 9? Well, how about this? Square root of 9. This is equivalent to square root of 9 squared. As we've mentioned earlier, the square and the exponent cancel. 9 is 9. Another way to look at this would be this way. What number multiplied by itself gives me 9? How about the number 3? 3 times 3 gives me 9. So now we have a couple different representations of the same thing. So the number 3 I have represented a couple ways. I have it as 9 to the 1/2, and I have it as the square root of 9. And you remove those, put equal signs. Okay. So what we have shown, I hope I've convinced you that a fractional exponent, for example, 1/2, is the same as the square root. 1/2 square root. Okay? So let's go back to my 8 to 2/3. See if we can figure this one out. Well, I know that 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3 equals 8 to the 1. Now what number multiplied by itself 3 times gives me 8? How about 2? Something like that. Okay. 2 is also the cube root of 8. Okay. So just like there with the 9 to the 1/2 or the square root of 9, these three, those are equivalent to each other. 8 to the 1/3 is the same as 2, is the same as the cube root. Third cube root. That's what a fractional exponent is. Now let's look at this 2 up here. So if I have 8 to the 1/3 times 8 to the 1/3, that's 8 to the 2/3. And we just decided 8 to the 1/3 is the cube root of 8. And we also just decided that the cube root of 8 is 2. There we go. So 8 to the 1/3 is just the cube root of 8, which is 2. We did that twice, and we get 4. So let's take a look at this another way. So we have 8 to the cube root squared, and we determined that the cube root of 8 is 2, so this is going to be 2 squared equals 4. Well, what's stopping me from writing it this way? Can I write it this way instead? Cube 8 squared. I'm going to put an equal sign at the question mark. Let's figure this one out. Okay, so we'll follow orders of operations as we do the parentheses and exponents first. So it's going to be the cube root of 64. So now we need to factor this one. So how about 4 times 16? And we can do that one. 4 times 4 times 4. Hey, look at that. It's a cube. I got 3 inside, so this is 4. As is this one. So this says these two are equivalent. So I can go ahead and erase that question mark. Or more succinctly, eight to 2/3 equals the cube root of 8 squared, and it also equals the cube root of, so squared of the cube root, or 8 squared cube root, which also equals 4. So that's fractional exponents from this direction. Let's try one example going the other way. How about 7 to the 5th to the squared? Write this as a fractional exponent. It's going to be 7. This guy out here is my denominator, and this guy up here is my numerator. 7 to the 2/5. Now, evaluating this is a different story. You can evaluate this on your calculator by going 7 caret 5 divided by 2 equals. That's how you can do it on your calculator. That's how you would do these sort of things.